So, good morning, everyone, and welcome to this lecture. This is lecture 3, and we are dealing with the motion of the center of mass. I think I given you a question in the previous class. Anyone tried it? Did you get any answer? I think this was the question. A pulley fixed to a ceiling carries a string with bodies of mass M and 3m attached to its end. The masses of the pulley and the strings are negligible. Friction is absent. What is the acceleration of the center of the mass of the system? Anyone does? Anyone did it?
We did not answer.
You did not try it?
We did not get the answer, sir.
You should have got the answer. If you don't get the answer for this one, there is a problem somewhere. What was the problem here? Tell me. What was the problem? Tell me what was the problem. Then I will tell you the solution. How do we find out the acceleration of the center of mass of the system? What did you try? Tell me. What did you try to do? If you don't tell me what did you try to do, how will I tell you? Just telling you the answer is not going to solve. Just telling you the solution is not going to solve anything. Because again, if the same question comes, you will not be able to do it. No one understand a question by seeing the solution. I never did that. And I don't see any student doing that ever. Unless you understand what you were doing, and then unless I understand what you were doing, I will not be able to help you out. Just telling you the solution is not the solution. Tell me what you tried. Did not try? Try it now again. Try it now again. The first thing that you can do is to draw a diagram. I guess you can all draw the diagram of this. The diagram is as simple as it gets. We have done around 15-20 questions of this type. If you cannot do it, that means you have forgotten what we had done some 15 days back. If you forget what we have done some 15 days back, after 3 months or 4 months or 6 months, you are going to exam. You are definitely going to forget what we are going to do today. So it is of no use. Let us shut down this class and finish your course, because there is no point of doing the course anymore. If you can't remember what we had done in 7 days back, you will definitely not remember what we have done 7 months back. What is the point of taking the class? There's no point of taking the class. You should be able to do what we have already done. You should be able to do it. You have to find the acceleration of center of mass of this system. So which formula are you going to apply to do it? Which formula are you going to apply to do it? Yes, bacha? You're going to apply M1A1 plus M2A2 upon M1 plus M2. This is the only formula to calculate the acceleration of center of mass of this system. You just have to find A1 and A2. You cannot find A1 and A2?
We can.
You should be able to. Do it. Find it out. Get the answer. The only way you are going to solve any question in a JEE is when you do it on your own. If you just look at the solution, you will never solve any question in a JEE. That is the problem that most of the students have. Sir, class में सब कुछ समझ में आता है, question नहीं बनते. क्यों question क्यों नहीं बनते? Why are you not able to solve question? Because you have not done it with your own hands. That's it. You just copied. Even my 8-year-old kid can copy from a whiteboard. Anyone can copy from a whiteboard. The only way you are going to clear JEE or to Solve question in a JEE by solving it with your own hands. Then you see what mistakes you make. Looking at the solution, you are not going to understand anything. So I'll give you 2 minutes to do this. You should be able to do this.
Sir,
Yes, bacha.
it's G/4 downwards, sir.
See, you got the answer. G/4 downwards. That is the answer. Unless you try, you will not succeed in life. So how do we do this? We already know this is mg, this is t, this is 3 mg, this is t. We know where it is going to move. This block is going to move down with an acceleration a. This block is going to move up with an acceleration a. What is the equation of motion of this block? Tell me. Same thing. What is the tell me. 3 mg minus t is equal to 3 ma. Yes or no?
Yes, sir.
What is the equation of motion of this block?
T minus mg is equal to ma.
T minus mg is equal to ma. You can now add both this equation and get the value of a. What is the value of a that you are getting?
G/4.
A
Sorry,
is g/4. Pakka?
G/2, sir.
A is g/2. Now we put this in the equation that we have got. Simple. So my acceleration of center of mass, I call this block as block number 1 and I call this block as block number 2. So m1, what is the mass of block number 1? M,
E,
I take upward as positive, m into g/2 plus 3m into
G.
minus g/2 because it is going down. Do we understand this?
Yes, sir.
m1 plus m2, m plus 3m, and we land up with the answer. What is the answer we are getting?
G/4.
With a minus sign, that means it is going down with an acceleration of g/4. Was it tough? It was not tough. Unless and until you do it with your own hands, you will always find things tough. So, shall we move ahead?
Yes, sir.
Okay. Now coming on to the center of mass, we had seen the velocity and the acceleration of center of mass and the momentum or the momentum of the center of mass. We all remember this, yes or no?
Yes, sir.
Now, if the external force acting on the body or the system of bodies is 0, that implies the acceleration of the center of mass of the body will be 0, yes or no?
Yes, sir.
That implies the momentum of the system would be equal to constant? Yes or no?
Yes, sir.
Why it is constant? Because you must know. Okay, let us first deal with momentum and let us go back to momentum again. Let us first deal with linear momentum. So I can write the heading linear momentum. What do you mean by linear momentum? Is the product of
Mass and velocity.
mass and velocity. It is denoted by the letter P. P is equal to m into v. Yes or no?
Oh,
Now this can also be written as v can be written as, or if I differentiate both sides, dp by dt can be written as m into dv by dt. Yes or no?
yes, sir.
That becomes m into a. That becomes equal to f. Yes or no?
Yes, sir.
So the rate of change of angular momentum is the force acting on the particle. Yes or no?
Yes, sir.
Well, then if the force acting on the particle is zero, or the net external force acting on the particle is zero, that implies that dp, the change in momentum, is zero. Yes or no?
Yes, sir.
That implies the momentum of the particle will remain constant. Yes or no?
Yes, sir.
This statement is known as law of conservation of linear momentum. What is the law of conservation of linear momentum? I will call it as law of conservation of momentum. We had seen law of conservation of mechanical energy. Now this is law of conservation of momentum, LOCM. Law of conservation of momentum. What does this state? If the force acting on a particle is zero, that implies momentum of the particle is constant. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Wrote it down.
Done, sir. Done, sir.
Okay. Okay.
Yes.
You can solve this question based on this. Simple question. Solve it and get your answers.
Sir. Question.
Yes, I'm putting the question. Beta. So this is the question. The rate of burning of fuel in a rocket is 50 grams per second. and it comes out with a velocity of 4 into 10 to the power 3 meter per second. What is the force exerted by gas on the rocket? I'll give you 2 minutes to do this.
A, sir. Option A.
Okay, well done. Anyone got the answer?
Yes, sir.
Option A, how did you get it? You just have to find out the rate of change of momentum. And how do you find the rate of change of momentum?
Mass into velocity.
Huh? The momentum of this, if I don't write it, the scalar m into v. I had to find out the rate of change of momentum. Here the velocity is constant, so I can write it as m into, no, I can write it as v into dm by dt. Yes or no?
Yes, sir.
You just have to convert the mass rate, which is given in grams per second. You need to convert it into kilograms per second and then multiply it by the velocity with which it is coming out, and you are done. Yes or no?
Yes, sir.
Okay. So these are simple examples of momentum. Now, where are you going to apply this law of conservation of momentum? Now, we have seen the law of conservation of momentum for one particle. If the net external force acting on one particle is 0, we can say that the momentum of that particle remains constant. Now I can apply the same thing, LOCM, for a system of particles. Now, I already know that momentum of a system of particles can be written as summation of pi, yes or no?
Yes, sir.
And that is nothing but equal to the momentum of the system of particle is nothing but equal to total mass of the system into velocity of center of mass, yes or no? We have arrived at this result, yes or no?
Yes, sir.
Now, if I differentiate this equation, rate of change of momentum of the system will be equal to m into rate of change of velocity of center of mass with respect to t, yes or no?
Yes, sir.
So that becomes m into acceleration of center of mass, and that is nothing but equal to the external force acting on the system of particles, yes or no? You've seen that in the previous thing. Now if I say, if the external force acting on the center of mass is 0, I can say that the change in the change in the momentum of the system of particle as 0, or I can say the momentum of the system of particles is constant. This is known as law of conservation of linear momentum for a system of particles. more than one particle. If the external force acting on a system of particles is zero, the momentum of the system of particles will be same. Do we understand this?
Yes, sir.
Now we can see some examples, and those examples are not examples, but those examples are actually questions. So we will do those questions in terms of an example. The first example, and I will just, the first example is this. When a bullet is fired from a gun, do you see a bullet fired from a gun, or a shell throwing a bomb? When the shell throws the bomb, or a bullet is fired from the gun, the man who is holding the bullet, the man who is holding the gun feels a recoil velocity. Yes or no?
Yes, sir.
He is shifted backwards. Or when a fire hydrant is held by a fireman, as soon as the water comes out, this fire hydrant goes back. We call it the recoil velocity. Which velocity we call it?
Recoil.
Recoil velocity. You understood now what I'm going to say? Now, this V is basically your recoil velocity with which the man or the bullet or the gun is pushed back. Now, how do you find this recoil velocity? Let us say that M is the mass of the gun with man, small m is the mass of the bullet, V is the velocity of gun which it comes back, V is the velocity of the bullet with respect to ground. When we are holding this gun, the initial momentum of the system is zero, yes or no?
Yes, sir.
Then this gun is fired. The gun moves with a velocity of v with respect to ground. So we will be pushed back with a velocity of v. Yes or no?
Yes, sir.
Final momentum should also be zero. So you can find out the final velocity of the man with respect to ground. Capital V will be equal to small m divided by capital M into V. Remember here this velocity of bullet is given with respect to ground. Sometimes it is not given with respect to ground. Sometimes this velocity V is given with respect to, sometimes this velocity V is given with respect to the gun. Sometimes this velocity V is given with respect to the gun. If V is given with respect to the gun, that time V is known as muzzle velocity. What it is known as?
Muzzle velocity.
Then that time it is known as the muzzle velocity. In that case, the formula changes and the formula for V becomes m upon m plus capital M times V. You remember this?
Yes.
Okay. So you can note this down. I'll give you 2 minutes to note it.
Done, sir.
Okay. Then you can use this case as case number 2, where I'm just finding out the cases which are more which are coming more in the examination, and this is the second case. In this case, what is happening is you have a bullet of mass m, small m, moving with a velocity v. It gets into a wooden block, and then it gets embedded in the wooden block, and the boat starts to move together. Do you understand this case?
Yes, sir.
The mass of this wooden block, as you can see, is capital M, and this entire thing starts to move with a velocity v. Right? Again, we are applying law of conservation of momentum here. The initial momentum of the system is small m into v in the forward direction, yes or no? The final momentum will be small m plus capital M into v. From there, you can find out the velocity of the system. Do we understand this? Yes or no?
Yes, sir.
Okay. So you can note this down. Here also there would be this type of collision. This is actually a collision. Yes or no?
Yes, sir.
This type of collision is actually known as inelastic collision. It's perfectly inelastic collision. In fact, some amount the kinetic energy is not conserved. The energy is not conserved. Energy is conserved, but it is converted into a form of heat. So the final kinetic energy of the system will not be equal to the initial kinetic energy of the system. There will be some energy will be lost, and that is the formula of energy that will be lost. You can remember this formula, or you can always find the initial kinetic energy. You can always find the final kinetic energy, and then you can subtract the both. Else you can now note it down and note it.
Done, sir.
Okay. So this is one case where it gets embedded. Now there could be a case where it does not get embedded. It actually comes out So so that is also one case, and I think you can just note it down as a different case so that if this question comes, you can straight away use this. It does not have anything. It's just law of conservation of momentum. So this bullet is initially moving with a velocity. All these are questions. I hope you understand this. All these are questions with their solutions. I hope you understand this. Yes or no? Yes or no? All these are questions. So the bullet initially, as you can see, is moving with a velocity m. It's mass m and moving with a velocity v. After that, it hits a block. It moves out of the block. The block starts to move, and this bullet is also moving. The block of mass m is moving with a velocity capital V. This gentleman is moving with a velocity v1. Again, momentum is initial momentum is m into v. Final momentum is capital M into v plus small m into v1. Do we understand this? Yes or no? All these are questions. Please understand that all of these are questions.
An answer.
Everyone done this?
Yes, sir.
Okay. Second case, we are doing them case by case so that if they come, they are actually. Now, I've seen a lot of questions coming on this bomb. Now, sometimes this bomb is at rest and it suddenly breaks. Sometimes it breaks into two particles. I think I lost connection. Just give me a minute. Okay. Am I visible now?
Sir.
Okay. I'll just, where is this? Okay, it's here. Okay. Sometimes this bomb which is at rest, it explodes suddenly. Now, sometimes it might explode in two fractions. Sometimes it might explode in three fractions. Remember, if it explodes around one direction, momentum will be conserved in one direction. If it explodes in two direction, momentum will be conserved in all the two directions. Do we understand this? This is the case where it is exploding in only one dimension. So this is a bomb. One part will go here. If one part goes here, the other part will go here. Yes or no? If it explodes in two dimensions, so if one part goes here, the other part will go here. Yes or no?
Yes, sir.
It explodes in three dimensions. I mean, it explodes in two dimensions. So this is bomb. One part goes here, one part goes here, other part goes here. So what you have to do? You'll have to apply law of conservation of momentum in x direction as well as in y direction. I will see a question and I'll solve it for you. Okay?
Yes, sir.
Okay? Chalo. Right now, this is a bomb exploding suddenly, only two particles. So if one particle goes forward, the other particle has to go back. Do we understand this?
Yes, sir.
Note this down.
Done, sir.
Everyone got it?
Yes, sir.
Okay. One more case. Why I'm doing it as cases, because I know that this same question is going to come in the exam, and I don't want you to solve it. You can just read it here and you can just put the same thing here. Now, in this case, what is going to happen is the same scenario, but here the bullets get embedded and this block gets up. You must have seen this question, yes or no?
Yes, sir.
Same momentum conservation. Initial momentum mv, final momentum m plus mv. So the velocity which with the block and the bullet will move will be mv upon m plus v. Here energy is not conserved, but after this point energy is conserved, yes or no? So you can apply law of conservation of energy from this point, and the normal question that is asked is what is the height to which this system will rise, and this is the height it is applied, it is gained by law of conservation of mechanical energy. Do we understand this?
Yes, sir.
We are doing all the questions as cases so that if a case comes, you can just do it from these cases. So just note it down. Have we done this, bacha?
Yes.
Okay, then comes this question, and I hope you can solve this question. Question number 1. A projectile is fired. This is bomb exploding. A projectile is fired with a speed of 100 meter per second at an angle of 37 degrees with the horizontal. At the highest point, the projectile breaks into two parts in the mass ratio of 1:3. The lighter part coming to rest. Find the distance from the launching point to the point where the heavier particle lands. This is a very famous question. It has come many times and given you. I hope you can solve this. You have 2 minutes to do this. Try it. Yes, but shall I solve it?
No, sir, we are doing.
Okay, try it. Shall I help you better? I think you are lost somewhere.
Yes.
Now see, the projectile is exploding because of what? Because of internal reactions. Yes or no? It's exploding because of internal reaction. So what will happen that because of this internal reaction, internal action, internal forces, the motion of the center of mass, there is no external force causing this explosion. So if I take the original case, if I take the original case of how this projectile was supposed to go and how it will go after explosion, we will understand that. See, this is the original projectile. It was supposed to go like this, u theta, and it was supposed to land here. Yes or no?
Yes.
Now, the only force acting on this projectile initially was gravity. Yes or no? At this point, what happens is that this projectile explodes. Now, even when this projectile explodes, it explodes because of internal reactions. That means whatever happens, the only external force before the explosion and after the explosion was same. It was gravity. It explodes because only of internal reaction. The center of mass of this projectile is always going to land at the same point because the explosion does not change the motion of the center of mass, because this explosion only happened because of internal forces. Do we understand this? Yes or no? Now the first of the particles, it comes at rest, so it will just fall vertically down. So it comes at rest, it will fall vertically down. The mass of this particle is small m. The second particle now, which has a mass of 3m, should fall in such a way. So this is the point where, let us say, this 3m mass is going to fall. It should fall in such a way that the position of the center of mass, where the center of mass is supposed to fall, would remain same. Do we understand this, what I'm saying? So that is the theory of this question. Now, we know that where this center of mass was supposed to fall, where the center of mass was supposed to fall, the center of mass or the particle was supposed to fall at the range R. Yes or no?
Yes, sir.
You can find out the range. Tell me the range of this projectile.
400 meters.
What is the range of this projectile? 960 meters is what I have been given. So this was the original position where this was supposed to fall. One of these particles has already fallen at r by 2. It has already fallen at 480. Yes or no?
Yes.
So if I call this total distance where it falls as x, you can find out the value of this x. How can you find out the value of this x? Total mass is 3m plus 4m. Yes or no? The
Yes.
position of the center of mass, the x coordinate of the center of mass will be given by m1x1 plus m2x2 divided by m1 plus m2. In this, you know everything apart from x2. You know x position of center of mass is 960. You know the coordinate x1 is 480. The mass of this particle is
1.
m. You just need to calculate the value of x2, which is this x. The value of this mass m2 is 3m. Where does this fall? Where does this fall, bacha?
1 minute.
It's taking so long for you to calculate it, beta. It should not take so much of time. This is pure math, simple maths. You should do it quickly. If you can't calculate the question quickly, that is a very, very bad sign, beta. It's a very, very bad sign. It's a very bad sign if you can't calculate it quickly. You're taking so much of time. Not accepted. Not accepted. There is no point of studying physics. You must study maths. This is not even math. This is simple calculations. You must spend more time in your calculations, beta. You are too weak in calculations. And this is going to cost you dearly. Should you take so much of time to calculate this? Plus, minus, multiply, divide? No. Please forget about physics, forget about chemistry, forget about maths, start calculations. Because physics, maths, chemistry is of no use without you not able to calculate this. It will be of no use, bacha. Whatever I tell you, whatever I teach you, it will be gone down the drain. If you can't calculate this, you've taken 3 minutes to calculate a simple calculation. I can't give you any more time, and the answer is 1120. You've just taken too long to calculate it. Taken too long to calculate it. I could calculate this thing in my head. You know, I'll tell you how I don't have the calculation right in front of me. I'll calculate this in my head, and you will see how quickly I can do. XCM is 960, and here it is 4m. So 960 multiplied by 4m. Forget about m. M is going to get cancelled. 960 multiplied by 4 minus m. M is gone. M multiplied by 480.
Yes.
So it is 960 minus 960 multiplied by 4 minus 480. I can write 960 as 480 multiplied by 2. So it is 480 multiplied by 8 minus 1. So it is 480 multiplied by 7 divided by 3. 480 multiplied by 7 divided by 3. If I divide 480 by 3, I will end up with 160, which multiplied by 7, and you get your answer. You can do it bloody orally. You've taken so much of time. It is yuck. It's absolutely not accepted. So the only thing that you got to do, forget physics, forget chemistry, forget maths, forget integration, forget differentiation, do calculation like this, because even if you know how to do this, you will not be able to calculate it. So what's the point of doing it? Very sad day. I did the same thing. I am an old person. I don't know how to calculate. I make a lot of mistake. I can do it orally. You have got copy, pen, pencil, everything. You still can't do it. When I was of your age, I used to just write this formula and say done. हो जाएगा. And I used to calculate in my head, approximately इतना आंसर आना चाहिए. I used to take answer आगे हो गया. And for you, the main task is calculating this. Not accepted. This is below expectations. If you can't calculate this, you are aspiring for the wrong exam. You must aspire for 8, 9, 10 ka maths ka exam. That is what you're looking at right now. You can't aspire for an IIT if you can't calculate this. Anyways, I hope better things will prevail and you will work on your calculation. The problem with you guys is you have never done anything with your own hands. You've always looked at the board and felt happy about it. Wow, what a good problem sir has done. I will copy it and I will become a good student. That is now how you are going to clear an IIT. Unless you do things with your own hands, you are not going to clear an IIT. And this is the result of you not ever doing anything with your own hands. You cannot calculate this. Please don't miss on a chance to get into an IIT because of a stupid calculation. Time is a luxury, bacha, we don't have. Exam, you will not find any time to do anything. And if you are taking 3 minutes to solve this simple problem, calculation part, here it will take 6 minutes for you in the examination hall. If you solve one question in 6 minutes, how many questions are you going to solve? 10 maximum. You are done. Even before starting the exam, you are done. You will take twice as much time that you are taking now in the class to solve the question, twice as much time. So if you are taking 3 minutes to solve it now, you will take 6 minutes in the examination hall and you are done. Even before giving the paper, you would be done, beta. Please work on your calculation. This is not something that will require a lot of 15 hours of practice. It will you just start doing calculation, do calculation, and in 2 days you will be good. If you can't calculate it, there is no point of studying physics. I hope I have made the point very clear in your head. Yes or no?
Sir.
And do not always use your copy and pen to calculate everything. Use this. Use this. That can do the thing very quicker. If I would have used copy and pen, I would have written 960. See how much time I'm wasting. Is equal to m into 480 plus 3m into x divided by m plus 3m. In this time, I should have calculated the answer, in which I have written it only. I calculated in this much time, yes or no? And in this much time, I have already written what I have to do. But orally, I did it before this writing stuff. I've told you my thing. I hope you work on that. Use your brain to calculate. If you have to calculate using a copy and pen, you are done. You understand the meaning of done? Done. You will not get time to calculate in a copy and pen in the examination hall. Because if you're starting to use copy and pen should be used to do the physics part. Calculation part should be in the head. Are you getting my point?
Yes.
Copy and pen only for physics. Calculation in the head. Copy and pen physics. Calculation head. Copy and pen physics. Calculation head. Try it. Your head will start to work. Everyone has got a head. But you use it, then only you will be able to use it. Getting my point?
Yes, sir.
Okay. So do it, practice, and you will become perfect. I hope in the next class, as soon as I give you what is the answer, you will tell me the answer is this.
Sure, sir.
Okay, well done. Take care. And may God bless you. Do not what I've said, take them to your heart. Feel bad about it and then work on it. It's not it's meant for you to feel bad. No?
Yes.
You're supposed to feel bad and then only you will improve. So you're supposed to feel bad. So feel bad about it, but then work on it. Okay?
Yes, sir.
I've said it very seriously. I've said it very seriously. Please work on it. Take care.
Thank
Have
you.
a nice day. Work on it. It's very simple. You can do it in one day, not more than one day. Bye.
Nice.